Hello. Today we are going to learn about an interesting phenomena about perception called as depth perception. It is one of the ability that we have which allows us to see the world in three dimensions. It is this ability because of which we are able to pick an object correctly at a distance, or we are able to maintain distance from the people ahead of us while walking, and we do not hit them. It is such a handy ability that we don't even realize that we have it. How early in human life does this ability develop? Is it present at birth? This ability to see the world in three dimensions is not actually present at birth, but it seems to develop very early in infancy. People who were blind from birth and who have had sight restored have almost no ability to perceive depth. How do we perceive depth? Various cues exist which help us to perceive depth in the world. Some cues require use of only one eye. These are called monocular cues. And some cues result because of the use of both eyes. These are called binocular cues. Now let's understand some examples of monocular cues. Monocular cues are often referred to as pictorial depth cues because artists use these cues to give illusions of depth to paintings and drawings. Some examples of these cues are: first, linear perspective. Have you ever seen long railway lines or a long highway? Look at this picture. These two lines of the railway track appear to merge together at a distance, right? This tendency for the lines that are actually parallel seem to converge on each other is called linear perspective. These converging lines give us cue of great distance away. We experience the same phenomenon when we are traveling on a long highway as shown in this picture. The second monocular cue is called relative size. When objects that people expect to be of a certain size appear to be small, then it is assumed that these objects are much farther away. For example, a friend who is 6 feet tall appears to be smaller. It is assumed that he is standing very far away. Here, the principle of size constancy has worked, which is explained in another video. Though the image of the friend appears smaller on the retina, we still perceive him as tall. This is called size constancy. Movie makers use this principle to make their small models seem gigantic but off in the distance. Look at this picture. The goats which are far away appear to be smaller than the one which is closer to camera. The smaller images of goats give us a cue of distance. The next monocular cue is called overlap. If one object seems to be blocking another object, people assume that the blocked object is behind the first one and therefore farther away. For example, you are finding an address of building C which seems to be blocked by building A. Then you understand that building C is farther away than building A. This cue is also known as interposition. Look at this picture. The next monocular cue is called as aerial or atmospheric perspective. The farther away the object is, it will appear hazier due to tiny particles of dust, dirt and other pollutants in the air. This is why distant mountains often look fuzzy and buildings far in the distance are blurrier than those that are close. You can see this in the picture presented on your screen. The mountains far behind seem hazier than the mountains in the front. The next monocular cue is called texture gradient. Take a look at any large expanses of pebbles, rocks or patterned roads such as cobblestone street. The pebbles or the bricks that are close to you are very distinctly textured, but as you look farther off in the distance, their texture becomes finer and smaller. This streak of texture gradient is used by artists to give illusion of depth in a painting. In this picture on your screen, you can see the details of broken soil parts which are closer, but the parts at distance appears to be smaller and finer. The next monocular cue is motion parallax. You might have experienced this when you are traveling in a car or a bus. Objects outside the window seem to zip by very fast when they are close to the car or bus, and the objects in the distance, such as mountains, seem to move very slowly. This discrepancy of motion of near and far objects is called motion parallax. This discrepancy serves as a cue to tell us which objects are closer and which are far away. The next monocular cue is accommodation. This monocular cue is not one of the pictorial cues. Rather, it makes use of something that happens inside the eye. The lens of human eye is flexible and held in a place by a series of muscles. This lens has a tendency to change its shape or thickness in response to objects near or far away. This is called as process of visual accommodation. The brain can use this information about accommodation as a cue for distance. Accommodation is also called a muscular cue. These were some examples of monocular cues. Now let's understand some binocular cues. As the name suggests, binocular cues require use of both eyes. Let's understand the first binocular cue, which is called as convergence. Hold your finger in front of your nose and then move it away and back again. You will notice the feeling in the muscles of your eyes. This is called as convergence. It refers to the rotation of two eyes in their sockets to focus on the single object. This is another muscular cue. The next binocular cue is binocular disparity. Now to understand this cue, hold a pen in front of your nose. Close one eye, note where the object is, and then open the eye and close the other eye. There will be quite a difference in views. Now hold the pen at almost a hand's distance away from your nose. Close one eye, note where the object is, and then open the eye and close the other eye. Now this time the image does not seem to jump or move. This is the cue called binocular disparity. Our eyes are a few inches apart and therefore they don't see exactly the same image. The brain interprets the images on the retina to determine the distance from the eyes. If the two images are very different, the object must be pretty close. This is what happened when you held a pen in front of your nose. If they are almost identical, the object is far enough away to make the retinal disparity very small. This is what you experience when you held a pen at a distance. Now let's reflect on what we have learned today about depth perception. Please take a paper and pencil and answer these questions. Question 1. When you are looking at the pigeon sitting on the roof of the balcony of the building in front of you, certain muscles in your eyes relax, but the same muscles are contracted and alter the shape of your lens when you are looking at the pigeon sitting on a bar of your window. This cue is called as. The answer of the question 1 is accommodation. In this picture, the shape and texture of tulips closer to camera are distinctly clear, but the details of the tulips behind are not very clear. This is example of dash cue. Answer of question 2 is texture gradient. This image is example of dash dash cue. Answer of question 3 is binocular disparity. Question 4. Arun lifted his heels to take a bag which was kept on the cupboard. He could gauge the height and distance of the bag correctly. This ability is known as dash dash. Answer of question 4 is depth perception. Question 5. Sitting at the window of the train, Rita was enjoying the speed with which trees nearby were moving away. But she was wondering at the same time why the river behind trees was appearing to be still. In this example, which cue was Rita experiencing? Answer of question 5 is motion parallax. Question 6. The haziness of the mountain at the back makes us to understand that it is far away. This is the example of dash cue. Answer of question 6 is aerial perspective. Question 7. The trees in the distance in this picture seem to converge. This is an example of dash dash cue. Answer of question 7 is linear perspective. Question 8. The tree behind is perceived as farther away in the picture because it is blocked by the tree which is in the front. This is example of dash cue. Answer of question 8 is overlap. Question 9. The new hostel seemed to be smaller from the college gate. From this, Ganesh understood that the hostel is far away. This is the example of dash dash cue. Answer of question 9 is relative size. Question 10. This image is the example of dash dash cue. Answer of question 10 is convergence. Question 11. What is the difference between monocular and binocular cues? And answer of question 11 is monocular cues require the use of only one eye, whereas binocular cues require use of both eyes. Good. Thus, in this video, we learned that what is depth perception, and we learned some examples of monocular and binocular cues which we use for perceiving depth in the world. Thank you.